So we're going to attempt to record this. So what we're going to focus in on today, our objective, is finding lines of best fit, or we'll say line of best fit, and making predictions. From an equation. So those are our two main goals that we get through today. And so we're in kind of two locations on this one. In the green book, so the green algebra book, let me change colors on here. It's lesson 7 that you can look at, and it's okay. And then on the online book, which, Jacob, I gave you information how to get on the online book. Disregard it because I got to get you on the other online book. So if you can come back and see me, then we'll get that taken care of. So interestingly enough, we're going to work from the online book today in class, but your homework's going to come from the green algebra book, right? So this is lesson 8.2, okay? And remember, what you want to look for is math trainers on the particular topic you're interested in. It's interesting, they do not have a math trainer for the line of best fit. What they do have in personal math trainers is something called residuals, and I'm just making a choice to not teach you about residuals because I think it's a bit much. So let's get a little bit of background, and then we'll try to do some drawing here. So first off, what do I mean by a line of best fit? And we kind of referred to this when we were looking at scatter plots before. And basically, you're looking for, in a scatter plot, and remember that contains bivariate data. So that means you're comparing two things and you're looking for a relationship. So it's a scatter plot with strong positive or strong negative correlation. Okay, so, and it only works for this. If you don't have a strong positive or a strong negative, then we really don't have much that we're going to deal with that plot other than, oh, that's interesting. It kind of looks like there might be a trend for this. As this gets bigger, that gets bigger. Okay? So line of best fit, a scatter plot which has the bivariate data with a strong or positive or strong negative correlation. You're going to draw a line that best represents the relationship of the data. Okay. So this line that we're going to draw is not an exact line, because if it's strong correlation, does not mean all the points line up. Okay, they're going to be kind of close, and you can find a line that kind of most the points are either on or touching, or very close, or it's equidistant from that line. So this is not an exact. So all of this is pretty much an estimation kind of process. Okay. So first thing we're going to do is come up with a scatter plot of a set of data. And then based on that scatter plot, we're going to use a ruler. So at home, you guys are going to want to use a ruler, an index card, whatever. to draw the line of best fit, okay? So on the worksheet that you guys have, they have a particular set of data where we're looking at the guided practice one, where you have years and the median ages of males, okay? So what was the median age of men in 1970? 26.8, okay? And this is from the U.S. Census. And then 1980 was 28.8, okay? So what is that, looking at 1970 to 2010, what do you notice about the males' ages? That's gone up. So there's not as many younger people, so people are getting older, so we have more older people, so it's taking the median, which remember is the physical middle. So they took every single man or male, I should say, because you don't have to be a man to be in a census. They took every single male, put their ages in order from least to greatest, figured out how many that was, found the middle, and for 2010 it was 35.5. Whereas in 1970 it was 26.8. Okay, so that means there was half of the population that was in the census was below 35.5, half of the population was above 35.5 in the 2010. Okay, so what we're going to do is take that data, and instead of using 1970, 1980, 1990, 2000, 2010, what are they using to represent the years? How are they showing the years in the chart, Patrick?
Years after 1970.
Yeah, so basically we start with 1970 as ground zero. So if you notice in that chart, we're going to take the data and we're going to, you can write on this if you want to put it in your notes, that's fine, but I would get these attached to your notes. So 1970, we're going to use as ground zero. In 1970, what was the median age of men? So you're going to fill in this chart. And then how long from 1970 was it until 1980? 10 years. So that's where the 10 is going to go into that next spot to represent 10 years later. And there were 28.8 men. And then we had 1990. Come on, you. I'm sorry, I'm having trouble writing. Which was 20 years later, and that went with 31.6. 30 years later, which was 2000. We had the 34.0. And then in 2010, which was 40 years later, we had the median was 35.5. So if we took that information, and we plotted that. And all we're going to focus in on is quadrant run, because these are all positive information. There's no negatives. So what you're going to look at is they've already kind of started a scale. What do you think this scale is? And they're actually missing something from this graph. Okay. What do you see that they're missing from this graph? Okay. They've got some piece of information like that are skipping from here, from these graphs. And part of those information is going to be numbers. And so there should be every other number. Now notice with a scatter plot, your two intervals can be different. So on the left side, it goes 25 to 45. What goes in between? 35. So they're counting by what? Okay. They're counting by tens, but actually each tick mark is 5. So what they're technically missing is they went from 0 to 25 on the first interval, and then they went 5 for the each ones. So remember we talked about that line break? That says I'm skipping a bunch of numbers because anything below 25 isn't isn't working for me. So this is the median age of males. And you've already got that on there. And then this one, they only showed this number. So what are they counting by on the x-axis? Maybe tens? 10, 20, 30, 40, 50. So they're missing the 10 and they're missing the 30. So they have a different interval for the time. And again, years since 1970, which they already have written in there. Okay, so then we would go ahead and plot those numbers. So let's see, at 0, we were at 26.8, so I'm going to say somewhere around there. At 10, we were 28.8, so that's 25, that's 30, so it's going to be a little higher. And then at 20, it was 31.6, so right around here. And at 30 years, it was 34, so that's up to here. And then at 40, it was at 35.5. So just basically there. So you can see that's not a straight line, right? I want a large. Okay. Oops, sorry. That's not a straight line. So what we're going to do is put in the line of what we think is the best fit. So this is when you would use a ruler. And you try to draw a line that went through as many of the points or had equidistant top and bottom. And this is where it gets a little bit interesting. Okay, so now what we need to do is to pick two ordered pairs on the line. So that's why you need graph paper to do any of this kind of graphing, because you got to find it. Now, I'll be honest with you, it may be impossible for us to find exact whole number points. So what we're going to do is just estimate. So for example, this guy looks pretty much on the mark of 20 and 30. And then we can also take this guy, which looks to be 0.25. And from that, you would create an equation from what we've studied. So here's the good news. I have a y-intercept. Okay, that's pretty cool. So when I do my equation, I have y, oh, sorry, I don't need that. I need slope. So slope is going to be 30 over 20, 25 over 0, subtract. I get 5 over 20, which is 1/4. So my equation would be y equals 1/4 x, and because this is the y-intercept, I say 25. Okay? So once you come up with an equation of best fit, it's not, and each person may come up with something slightly different. But again, this is why you have to use a ruler and you have to use graph paper. So let's say we're going to take this, and what if we say, I want to figure out what the median age might be in 2020. Okay? It's 5 years from now. So what I'm going to do, I'm going to go to the next screen. Take that equation, and if you make predictions, hold on, you can wait just a few minutes. We had y equals 1/4 x plus 25. What if we want to know 2020? Well, 2020 is now going to be 50 years, right? So we're going to let that represent our x value. So we get y equals 1/4 of 50 plus 25. This is going to go into 50 let's see, to 12.5, and we're going to get 37.5 years. It would be the predicted median age. Okay, so that's what you're going to be doing on homework tonight. Sometimes just coming up with the equation based on information they give you and making predictions, sometimes just coming up with the equation. All right, good luck.